What's up, gang? So in this video we are going to discuss interhalogen compound AXN. So let's begin with basic. This is going to be a long video. So AXN, the A is the central atom, XN is the side atom. So A, the central atom, F can never be. F is too small to become a central atom. For a side atom, iodine cannot be a side atom. It is too big. It can never be. And yeah, so n can only belong to 1357. We will discuss why so see, this is the configuration for all the halogen compound ns2 np5. So how can we excite it? The bonding center is only one can bond, whereas if we excite it a bit, three will bond. We will excite it again, see, 5 will bond. If I excite it again, 7 will bond. This is the reason why only AX3, AX5, AX7 type of interhalogen compound exist. This is the reason, basically, excitation and how does it works. It's a pretty basic example are these. So preparation, basically, this is the bonding, by the way. sp3 linear, ax3 sp3 t shape, ax5 sp3d2 square pyramidal, ax7 sp3d3 pentagonal bipyramidal. Now preparation, AX type, type 1 AX, like I2 plus F2 at minus 45 degrees Celsius, and solvent is CCl4. When I2 plus F2 are added at minus 45 degrees Celsius, a unstable compound IF is formed. It is very unstable. And I2 plus Cl2, it becomes 2ICl at 250 degrees centigrade, very high temperature. 5IF, IF is very unstable. It breaks down into iodine plus IF5, which is stable. Pretty simple and easy. Let's move on to AX3. We have 3 here, ClF3, BrF3 and ICl3. ClF3 is gaseous and it is made from Cl2 plus F2 350 degrees Celsius ClF3, or ClF plus F2 250 degrees Celsius ClF3. It is a toxic hypergolic gas. What does that even means, man? So basically it burns with a non-flammable, like a magic trick, they do, like they will take the ClF3 and put it on their hands and they will burn their hands, but it will not burn their hand, basically burns with non-flammable, the magic tricks type of stuff. The people that burn their hand with, this is it. Now BrF3, yellow liquid, Br2 plus F2 350 degrees Celsius, BrF3, same like this, BrF plus F2 250 degrees Celsius, BrF3. BrF3 is, in a solid state, in a liquid state, when electricity is passed through it, it becomes a conductor and breaks down into BrF2 plus and BrFO minus. Yeah, pretty simple. Cation and anionic part, conductor in electric field. Now ICl3, it is a solid. ICl3 is a solid lemon yellow crystal. ICl3, it does not exist alone. It exists in a dimerized state, I2Cl6. That's it, pretty simple. Now let's move on to AX5. AX5, we have ClF5, ClF3 plus F2 ClF5, IF3 plus F2 IF5. That's it. Now let's move on to AX7, I2 plus F2 214 degree centigrade, IF7. That's it, pretty simple. We don't have to study much about that, not in our syllabus. Properties are very important. Questions are asked on the basis of property, like they will give you property and ask which compound it is. So let's begin with physical state. Gaseous is going to be ClF3, liquid is going to be BrF3, and solid is going to be ICl. Color, lower interhalogen compound shows less color or light color. Lower interhalogen like small one, basically like ICl, stuff like that. And higher interhalogen compound like ICl5, IF7 are colored. More mass, more intense color. The intensity of color is directly proportional to the mass for a higher interhalogen compound. Magnetic property, all electrons are paired, so it is basically diamagnetic, so no magnetic, no field, it will be not be attracted, basically. Thermal stability, it is directly proportional to the electronegative difference. So IF, there is a high difference, so it is more thermally stable than ICl, than IBr. Reactivity, AXN is more reactive than A2 and X2, the respective, like ICl is going to be more reactive compared to I2 or Cl2. Hydrolysis, AXN plus H2O, it will make one oxyacid and a hydroacid. So more electronegative will make hydroacid and less electronegative will make oxyacid. For example, if we do the hydrolysis of ICl plus H2O, it will make HCl, which is, chlorine is more electronegative, so HCl will become, and iodine is less electronegative, so it's gonna make an oxyacid. And what will be, how do we determine which form it is? So the here it is +1, the iodine's oxidation state is +1, so here it should also be +1, because oxidation state does not change in addition of water, so it will become HOI. That's it, interhalogen compound, easy.